Okay.
You guys ready?
Yep.
Heavenly Father, thank you for this day. Thank you that we'll be able to meet and plus be able to learn. Thank you for all the blessings we have and over the internet. Say these things in the name of Jesus Christ. Amen.
Amen. Just 1 second. My internet's being goofy. Corey, and you need to close any of his games. My kids they know they're not supposed to use the internet while I'm on groups. Okay. Now hopefully you guys won't skip in and out.
There you go. Okay.
18 questions.
Oh boy, that's gonna be a challenge. Okay.
We can do
Do
this.
you want to start, Kaden?
Yeah, so I did number 3, I think.
Yeah, the last one, right?
True population proportion.
It's just P.
Yeah.
For the requirements for blah blah blah. I'm not sure.
Let's see, what are the requirements?
That's when it has to be greater than 10. I don't know.
Okay.
100 times 0.10, right? And if it's greater than 10 or something like that.
Well, I was going to say, do we use P or P hat for the
I think it's P.
requirements? But either way, it's going to be fine.
Yeah. But it's P hat, right?
So
I'm pretty sure. I wrote that down in my.
What are the requirements for a confidence interval?
N times P has to be greater than or equal to 10. And 1 minus
gotcha.
P times N has to also be equal to or greater than 10. So either way, I think it fits.
Yeah.
So for confidence and for hypothesis test.
So for the confidence one, you use the P hat and then the other one, right?
Right. I think that's right for the.
Okay, I just want to get that straight. So like when I'm on my own,
Yeah, I think for the hypothesis test, you use the P, and for the confidence interval, you use the P hat.
Yeah, that's what I have in my notes. So I'm hoping that's I wrote it down. Okay.
Yeah, that's what I have in my notes too. So hopefully between the two of us.
Good.
So that's 4 and 5. Both of them are good.
Okay.
At least I did the math, but did you guys also do the math really quick?
Yep, I did.
It all works. Okay, good. Don't want to just go on me. Use the following information for the next 5. A study of first-degree murder trials was conducted in another state. A random sample of 60 people on trial for first-degree murder was taken. Of these, 45 were found guilty. So X is 45, N is 60. I'm going to write that down. Find P, the point estimate of the proportion of first-degree murder defendants who are found guilty in this state.
So 45.
So isn't that just X over N?
Yeah. And I got 0.75. So
yeah.
Yeah.
That's all you do for that one. Find P hat. That would be
Yeah.
0.75, I guess.
Seems too easy, but
I know.
So margin of error.
Okay, I just wrote this down.
So we have to find the upper bound and lower bound for this one.
So can you
probably,
use
but they want margin of error first by itself. So
okay, but then you use that formula, right? The M equals.
Yeah, M equals. So 1 minus P.
What was P in?
It was what, 0.75? Is that what we just said?
Oh yeah. And it was 1 minus P divided by N.
No, 1
N?
minus P times P, and then divided by N.
Oh.
Does it matter that was P hat and we have to use P for this?
Well, because we don't have a
So then you just use the sample size. Okay,
Right.
I knew that.
0.003.
And then take the square root of that, and then
Square
multiply
root.
that by z, which for 95 is 1.96. So I get 1.4 for margin of error.
Oh, freak. Let's see. Square root of this equals this times 1.96.
Yeah, that's for 95%.
109. But I don't know what I did wrong.
Huh.
So I did 1 minus 0.75 times that number by 0.75.
Yep, and then divide by 60.
And then
You get
I
0.003 something, and then
square that
square
as
root.
0.055.
Yep, and then times 1.96. Okay, yeah, I must have hit something funny because
Okay.
Yeah.
that's why we do it.
0.10.
Yeah. Oh, it's 0.1095, so it's going to be to round it, 0.110.
10. Yep.
0.110.
That's why when I'm not with you guys, I do my math twice sometimes.
Okay. And for the lower bound.
Okay, so if
It's like the
Yeah.
mean minus the margin of error or something.
yeah, so our point is the 0.75, right?
Yeah.
So minus 0.75 minus
0.110.
1. So the lower bound would be 0.64.
0.64. And
And then
0.6.
0.6. Yep.
0.86, right?
Yeah. Okay.
What'd you guys get for that? Sorry.
No, that's okay. We're going really fast. 0.64 and then 0.86 for
Okay.
8 and
I was
9.
like, wait, you got 0.86 for the lower bound? Hang on. Okay. Because then
I think
Okay.
number 10 is decrease, but
If you increase the sample size from 60 to 80, what do you expect to happen to the width? Yeah, the more you increase the sample size, the narrower it gets. So the width would decrease. Good job.
would decrease.
Yeah.
Okay.
We're zooming through this for
I
you,
just had
Caden.
I know you're going so
What's
fast,
that?
I can't keep up.
Sorry.
No, you're fine.
I just had
You're
I had
totally
it
fine.
I had all the calculations in my spreadsheet, and then I just changed 60 to 80.
Oh, and a decrease?
Saw that it got smaller, yeah.
Yeah.
Oh, nice.
Yeah, it goes back to the same thing we talked about confidence intervals in general. So
Yeah.
it's an old question.
Okay, for
revisited to a
question
new topic.
11, can you guys walk through the steps with this? Because I'm still having trouble, like how to find what's the smallest for.
Yeah.
I can't remember how you guys did that.
Okay, so write it down on your paper in front of you.
Yes, I am.
N times P, and whether we're using P or P hat, it's the same basic requirements. It just changes
Okay.
that one variable. So N times P has to be greater than or equal to 10.
Okay.
And then N parenthesis 1 minus P, N parenthesis, has to be greater than or equal to 10.
Mm-hmm.
So the easiest way to do that is to say 10 divided by P, which in this case is 0.5.
Okay.
So for the first one, N has to be greater than or equal to 20 in order for that to work.
Why do you get 20?
Because I'm taking that equation and solving it for N. So you divide both sides by P, and you get N is greater than or equal to 10 divided by P.
Okay.
That's just the algebra of it.
Mm-hmm.
So when you
I
take
wish-
10 and divide.
Okay.
Sorry,
I wish
yeah?
they like listed out the steps in the textbook, but they don't.
Yeah.
So I'm
So
like,
that one is just 10 divided by P, and you have what N has to be at least or greater. So for the first requirement, it has to be equal or greater than to 20.
I guess I just have a hard time finding what it's supposed to be greater than.
Yeah, but for the second one, you do the same thing, only you have to do it with 1 minus p. So 1 minus p in this case is still going to be 0.5. So once again, 10 divided by 0.5.
20.
Yeah.
So they're both.
When it's not exactly half, then those two will be different numbers that you're dividing by, and you just want to pick the bigger one, because that will be true for both of them then.
Oh, I am so confused. Okay, I'll try to get it.
Yeah, I'm
So
sure they're
it's
going to have
20.
us do another one. But yeah, 20. When we do another one, you'll walk through it now.
There is another one. It's right after this one.
Oh, question 12. Here you go, Emily, your turn.
Oh gosh, I just don't know. Okay, so you said I don't know how you get so fast, like what number is supposed to be greater than. Like that's what keeps getting me. I don't know.
Yeah.
So P has to be equal or greater to than 10, and then it has to be, what was it? So it's the
What
same
was it?
requirements, n minus. So it's n times P has to equal,
Yep.
but greater than, and then n
N times p, 1 minus p.
times 1 minus P equal or greater than 10. Okay, so then,
So on this one, p is 1/10.
okay. So just 0.1. Then what do you do with that? You take that to both sides or something?
Okay, so you just have to take 10 and divide it by p to find out n then. So just write down a separate one. N equals 10 divided by, or 10, n is greater than or equal to 10 divided by p. That has to be true for the requirement.
Okay. I don't know what to do now.
And then for the other requirement, n is greater than or equal to 10 divided by 1 minus p.
Okay.
So then if you plug in p and do the math,
Okay. What is P? It's just point.
1. Yeah, 0.1.
yeah. So for the first one, what does n have to be bigger than or equal to?
So for the first,
100.
oh,
Emily?
Actually, I don't even know.
I'm figuring it out.
Okay, sorry.
0.9 and then 1 minus 0.1 divided by 10. Okay, I got 0.9 and then 0.09.
Okay, 10 divided by it. 10 divided by p.
I feel like that's what I just did.
So 10 divided by 0.1.
Oh, I must have done something weird because I feel like I just did that. So 100.
Okay, so the first one says n has to be equal or bigger than 100 in order for the requirement to be met.
Okay.
What about the second one? 10 divided by
So 1
0.9.
minus 0.1. Oh yeah, so sorry, 10 divided by. So 11.11111.
Okay, so that one says n has to be equal to or greater than 11 point whatever.
Yeah.
So in order to fit both of those, you have to go with the bigger one.
So 100.
Because if you say 100, then it fits the first one, n is equal to or greater than 100. And if you say for the second one, it has to be equal to or greater than 11, well, 100 is definitely greater than 11.
Okay.
So that works too. So 100 is the
I
answer.
get it. Thank you.
Yay!
Like my brain just opened up. Okay, thank you.
No
I
problem.
was
We were
like
rushing through
struggling
so
so
fast.
bad last night with that. Okay,
Yeah.
thank you. Moving on.
No problem. Okay, so for the water quality study and the reading, about 60% of the microinvertebrate water quality indicators have historically been associated with good health. They conduct a hypothesis test using significance level this. Oh, I skipped over that they suspect that the water quality has decreased. So the hypothesis test null is that it equals that. Alternative is that it's less than that because they think it's decreased.
Mm-hmm.
They collect new data, and this time n equals 80 and x equals 38 indicate good health. So the conditions for conducting a hypothesis test are satisfied, are they?
80 divided by 0.8. 0.6, sorry. Right?
No, you're multiplying. 80 times 0.6, right?
Oh, yeah.
Is bigger than 10. And then 80 times 0.4, which is 1 minus 0.6, is still bigger than 10.
So then, yeah.
Because for hypothesis, we were saying we use p, not p hat. Right?
Mm-hmm.
Mm-hmm.
Okay. So those both are bigger than 10.
So you're just doing the same thing basically as we were doing this previous question.
Yeah. Just this time we get to multiply instead of divide because they gave us different values.
Okay.
They gave us n and p. So we just have to make sure it's bigger than 10.
Gotcha. Okay. Got it.
Okay. Who's
So
up?
when you
Caden?
give an N and P, then you can just do that every time.
Yeah. If you have an n and a p, you can just check it really quickly.
Okay.
If they give you one and ask for the other, then you have to divide.
Gotcha. Okay.
So this one, we do that whole formula we did earlier, right?
All you have to do is take x divided by
X
n.
over n?
Yeah. So 38 divided by 80.
Oh.
I got
Okay.
0.475. So what do they want? 3 decimals?
Yeah. 3
you get that,
decimals. So
Kaden?
perfect.
Yeah, I got that.
Okay, cool.
Now we have to do the whole big formula.
Oh gosh.
The
Get
test
the test
statistic.
statistic.
The test statistic, yeah.
So 1 minus 0.6,
Well,
right?
so the top is going to be the p hat minus p.
Oh.
So that's going to be 0.475 minus, what is it, 0.6?
Yeah.
Hmm.
Over.
So the top, but then the bottom we have to do that other stuff. 1 minus 0.6.
The whole 1 minus thing.
Yeah, divided by n square root. Yep.
So it's going to be 0.475 times 1 minus 0.5, and then over.
Well, that's the question. I think we use just p, not p hat for that. Aside from the
1 minus 0.4.
the top one.
So it's 1 minus 0.6, then times that by 0.6 again.
And then divided by 80 and then square root.
So you're not using 0.475?
I'm using that just for the top because if you look at the equation that
I don't
wrote,
have the equation in front of me, so I think that's why I'm struggling.
I wrote down the equation for z, and it's the only place that p hat shows up is that first place, p hat minus p.
Okay, and
everything
then,
else is normal p. So if it's wrong, we can come back and fix it. But I think that's
so then you just do 0.6 times 1 minus 0.6. Is that what you're doing?
1 minus 0.6 times 0.6. Yeah, divided by n and then square root.
Okay. Sorry, Kate, I don't mean to slow it down today.
Oh no, we're almost
That's
done.
fine.
We're good.
Yeah,
I
and
think.
then do you you don't have to times it by the z-score or anything for this?
Right, because this is the z. The z-score of multiplication is just when we're doing like confidence interval.
Okay, so the answer would just be 0.055.
For the bottom part. Then you got to take the top divided by the bottom.
Oh, yeah. So minus 0.125 divided by this. So minus 2.282.
That's what I have.
Almost done, sorry.
Yep, see if you get the same thing.
Did you get a negative on top?
Yeah.
Okay. Oh, I got negative 41.666 or whatever.
Oh boy, what'd you have for your fraction there for the top and the bottom?
For the top, I have negative 0.125.
Uh-huh.
And then the bottom 0.003.
Did you take the square root?
Oh no, I didn't. Gosh dang it, sorry.
No, that's a common thing that I catch myself on.
So then I got for the bottom 0.054.
Yeah, so do that now and you should get the same thing.
Okay. So negative 0.125 divided by that. I got negative 2.28.
2. Yeah.
Yep.
Just make sure you put it to the right, the
2.28.
3 decimals.
Yeah, I was just reading. Okay, thank you. Negative.
Okay, then you gotta load up the normal probability applet.
Okay.
I always have to scroll back to the top for it.
I know. I don't know how my bookmarks work on my computer, so it didn't really help me that I because I
Aw.
can't do it now. I'm like, dang it. Uh-oh.
Oh, and we could be using Excel. It works. At least that's a good way to check our answers really quick, I guess.
So which part do you shade for the p-value?
They said less than, so just the left tail.
So 0.011.
0.011, yeah.
So what number do we plug into the applet?
The z-score on the left side, that negative 2.282.
The one we just did. Okay.
Yeah.
Negative. That's right. Okay. We just do the left side, right?
Yep.
So I got 0.0112. So what is it? 0.011?
Yep.
Sorry.
And then the alpha is 0.05.
Mm-hmm.
So
Fail to.
so the P is low. So we reject the null, right?
Yeah. If P is low, then we reject the null. That's sufficient.
So which one are you choosing?
Has decreased.
Yeah, there's sufficient evidence that it has decreased.
So if it's failed to reject, then it's
Sufficient.
usually sufficient evidence, right?
Yep.
We said it was reject for 17.
Reject?
Yeah, because
Oh.
P was low, so then you reject.
P is lower than alpha, yeah.
And when you
Oh.
reject, it's
For some reason I was thinking it was 0.11. That's why I chose.
Oh, yeah, that's 0.
Okay. So there's sufficient to conclude that it did decrease?
Yeah.
Yes, that's right.
Okay, cool.
All right, I'm gonna. Does someone else want to submit this?
Yeah, I'm submitting. It's fine.
Okay, thank you.
Yay, we gave you 100 for your birthday.
Yay! Hallelujah. That was a good birthday present.
And like I said, if you actually load up the categorical data analysis in Excel and just put in like 3 numbers, it gives us Z, P, all that. P
I was
hat.
like thinking about using it, but I think it's good practice for me to actually go through.
Yeah, it's good practice to do it. But
Is that a new spreadsheet?
yeah, it's the third one.
Yeah.
So look through
Cool.
the textbook and find it. I'm sure we'll be using it next week for the 2 proportions.
Yeah. Okay. So when do we have to have our like M&Ms counted by and stuff?
Well, first of all, we can keep talking if you want to cut the live, and then when you need to go, Emily and I can keep talking if we need to.